Okay, I'm just going to run through the PowerPoint slides that I sent through for the review task. So you should have completed this checklist and sent it back to me so I can see if you've had any problems. But we'll just have a look at some of the examples. So the first example, these are these peachy coloured slides. These are ones that you can read through, and all of these questions will be the ones that appear on the mathswatch homework. So here's an example of an expression, an identity, a formula, equation, and an inequality. So an expression doesn't use an equal sign, and you can't solve an expression. So this is an example of an expression, 6x plus 8. You can't do anything with it. It's like a statement. An identity is often shown using these 3 lines, so a little bit like an equal sign, but it's absolutely identical to. So both sides will have the same value, but will be written in a different way. So 6x plus 8 is exactly the same as 2 lots of 3x, which is 6, 8, and 2 lots of 4, which is 8. A formula can only be solved by substituting in values. So this is actually the formula to find the perimeter of a rectangle. So it's 2 lots of lengths plus 2w, which is width. We don't need to know what the formula stands for in this particular case. We just need to recognise that when you've got lots of letters, it's probably a formula. An equation has letters and numbers and can be solved by rearranging. So we've done some practice on this. This says that 6 lots of x, so 6 times something we don't know the value of, plus 8 equals 26. So I could use that information to solve that to find the value of x. An inequality is very much like an equation. You can solve it, but instead of using an equal sign, it uses an inequality sign, so less than or equal to, greater than or equal to, or greater than. We don't need to know necessarily what this symbol means for solving equations. We just need to know that we write this symbol instead of an equal sign. So in this case, 3x would be greater than, 1x would be greater than 4 if I was to solve that. So then you had some practice, and using that information that we've just looked at, you could see that this is a formula because it just has letters. This is an identity because it's identical to. This is an inequality. We can recognise it from the inequality sign. This is an equation, and this is an expression because it doesn't have an equal sign. We then looked at forming expressions using words. Now they look very complicated because they're very wordy. So the question would look like this. Batteries are sold in packets and boxes. There are 4 batteries in a packet and 10 batteries in a box. Sarah buys P packets of batteries and B boxes of batteries. She buys a total of T batteries. Write down a formula for T in terms of P and B. So it sounds very complicated. But if she had bought, say, 2 packets, we know that she would end up with 8 batteries because we'd do 2 times 4. If she'd have bought 3 boxes, we know she would have bought 30 boxes because we would do 3 times 10. We don't know how many packets or boxes she's buying, so for packets we're going to do P times 4, which is 4P. And for boxes, we do B times 10, which is 10B. So my formula, remember you can't solve a formula unless you know some values to substitute in for P and B, but my formula would be that the total is 4 times however many packets she buys, plus 10 times however many boxes she buys, and that would give us the total number of batteries. So the formula is T equals 4P plus 10B. So here was a very similar practice question. You had 12 sweets in a bag, and we were told that the bags of sweets were B, so that would have been 12B. And we had 40 sweets in a tin, and the tin was the letter T, so the total number of sweets, so S equals 12B plus 40T. Okay, we then looked at solving equations. So these were all different examples of solving equations. Remember in my previous slides, to undo something, you do the inverse. So on this one, something plus 5 equals 17. So if we subtract this 5, we can see that x equals 12. I've taken away 5 from both sides. In a similar way, remember you do the inverse. If something take away 3 is 8, we would need to add 3 and we would know that x equals 11. These look complicated. Something divided by 4 equals 3, so the answer is 12 because to undo that we multiply by 4. So if you see this that looks like a fraction, you just whoop it to the other side as a multiply. These 3 examples here are what we call multi-step, so we have to do a couple of steps to solve it. So the first thing we do here is to take away the numbers. So that gives us 3x is 21, and then we divide by 3. Okay, we don't subtract 3 because the 3 is 3 times a number plus 1 equals 22. So we need to undo it in reverse. So on this example, when you've got brackets, you multiply out the brackets first. So what I've done is 4 times x is 4x, and 4 times 3 is 12, and we're told that that's equal to 20. So I then reverse the proceedings. I take off 12 to get 8. So 4x is 8, so 1x is 2. And this looks the worst, but actually if you remember the one on the example 3, where if it's divided by, you just whoop it to the other side of the times. So the first thing I do is undo this divide by 3 by timesing by 3, so I can see that I get x plus 5 equals 12. I can then subtract my 5 to get x equals 7. So there was a few practice questions, very similar for you to try. And then we looked at making x a subject. Now a lot of people get confused with making x a subject. It looks very confusing, but you rearrange it exactly the same way as you do solving an equation. So we were told here that a plus x equals c. Now we can't solve this, we can just rearrange it because it's a formula. And when we're asked to make x a subject, we want to get x on its own. So you can see I've got a plus x, so I'm going to subtract the a, and that leaves me with just x this side. And then we had c, and we've taken away a, so on this side we have c minus a. Similar thing here, again with the x, we've got this a, so I need to subtract this a. I already have c plus b on this side, so I just need to pop a, subtract a next to it, and that gives me x equals c plus b minus a, because I've taken that over to the other side as a negative. Okay, on this one I'm told that y is 8 lots of x. So 8x means 8 times x. So to undo this 8, I'm going to divide. And in algebra we don't use a divide sign, we use the fraction as a divide. So that cancels that out. I've taken it over to the other side as divide. So y over 8 equals x. And this is a multi-step one. Y is 2 lots of x minus b. So I want to get x on its own. I've got 2 x's and this letter b. I'm going to undo that first by adding b. So y plus b equals 2x. And then like example 3, when I need to divide, I write it like a fraction. So I already had y plus b. I've now divided by 2, and that gives me x. And here were some practice questions for you to try. And then there were some worded examples. These are like the ones on the review as well. Again, they look a little bit confusing because they've got shapes and letters, and we had to find the value of y, and we were given no numbers. But if you look at this picture, all the letters are the same. So if I add up all the letters, I've got 3, 4, 5, and 1 here, which makes 6y. And I know that angles in a triangle add to 180, so I can form an equation that says 6y equals 180 degrees. So 1y must equal 30 because if I divide it all by 6, that gives me the value of 1y. So this angle here would be 60, because that's 2 of those, and this angle here would be 90, even though it doesn't necessarily look like 90 degrees, and they would all add up to 180. And here are some practice questions for you. A similar thing with the triangle, 180 degrees, so forming an equation, I can see that 6x plus 30 is 180. I could then try and solve that to find the value of x. And on this one, a four-sided shape adds up to 360 degrees, so we would have 5x plus 60 equals 360 degrees. I would then solve that to find the value of x. And here were the answers for those, and then that should lead you nicely into the mathswatch review.